morning. I was explaining to you in my last file of presentation of building construction guidelines about the concrete. Concrete slump, pouring by crane, pouring by pump, concrete temperature and concrete temperature, etc. And other precautions I explained to you in that file. Concrete is very important technology and we have to take much care of that. It's very important that all engineers, particularly in Bharat, may not be very clear about the technology, but it's not very difficult and it's easy to understand and to implement. In Middle East countries and other countries, all concrete is done by mechanical means, even produced by mechanical means, transported by mechanical means, and cured by mechanical means. And it's very nice. It gives very good quality. We should be proud of that we produce good quality there. Good means more than good actually it is, but it's not a big deal that we cannot do here. If we have the means, we can do very well. We are fully competent people here. Our contractors may not be, our builders may not be, and our other layman workers may not be that competent, but we can train them, we can force them to do what engineers want. And structural engineers and civil engineers, construction engineers here in Bharat are very competent because all those engineers who work there have been very successful in foreign countries, particularly in the Middle East and the Gulf. I am also one of them. I have been working in the Gulf for 15 to 25 years. Coming and going, but my total experience is 15 to 20 years in the Gulf, and I learned a lot of the concrete. So let's go to the next slide now. That is, let's say, it is materials E. I explained to you about the concrete slump and method of pouring. Then I'll go to slide 19, that is points to care, which is very important. Points to care says structural, provide a strong formwork, reinforcement cut and bend to designs, placed rightly in location, provided concrete plastic covers, vibrate concrete properly, very good curing. Now strong formwork. Formwork means shuttering. Shuttering should be very strong in vertical supports, in bracings. Every prop or every standard should be strong enough to take the coming load on that, load of the concrete, load of shuttering, load of people working on that and curing. All these loads should be efficiently taken by the system. And this system is nowadays given by the standard companies who are approved for this. They give all safety measures on that and give very strong designs. We request designs from them. Then reinforcement, cut and bend to designs. Particularly, there was BS4446, it was 8446, and we used that for the preparation of the drawings of bar bendings. That's called bar bending schedule, and that is very important. It has to be produced correctly, otherwise the steel rebars will be wasted. These should be placed in the right location. If not placed, then it will not work, it will not function properly. These are shown in the drawings, structural drawings, and these are in layers. Chairs are not shown in those drawings. These chairs have to be fabricated separately, and there should be no major variation in the dimensions, length, bending diameter, and all steel should be fixed on site, cut and bent to the shape according to the code requirement and according to practical experience. Structural engineers generally do not show everything on the drawing, but experienced engineers on site can manage that. They understand what is required, what is not required, and they cut the steel, bend it, properly transport it, sometimes fabricate it in the in the yard, and then transport it, and sometimes, particularly on the slabs, it is done on site itself. That's very efficient. It should be properly done based on the experience because it has to accommodate in it all the forces, particularly. Then it is provided concrete, plastic covers. Now, concrete is very important. It should contain steel in the proper position. Plastic covers or other covers, concrete covers are used. These are called spaces, small biscuit-type cubes of various dimensions depending on the thickness of the cover, and we either manufacture them on site by casting in frames, or we buy them or procure them from market as plastic covers. In foundations, particularly heavy foundations, we can't use plastic covers, so we use the concrete covers, and that concrete is also imported from the batching plants according to the design requirement. Of course, replacing the high size of aggregate to smaller size of aggregate. Plastic covers are used particularly for vertical sides of beams, covers, foundations, slabs, etc. 20 mm, 40 mm, 30 mm. Vibration of the concrete is very important. If concrete is not vibrated to catch a compaction, it won't be a dense concrete. Dense concrete is very good. Dense concrete is very important to achieve the strength, to reduce the permeability, to make it non-porous. Very good curing. What is curing? Curing is a treatment for the concrete. Wet concrete, when it solidifies, it solidifies because of curing. Curing means cement or any other material which when mixes with water, it reacts chemically, and there is generation of heat. That heat should be tried to be protected within, but it's not possible in the exposed concrete. It is evaporated into weather, into environment, and to compensate that loss of water from the used water, we have to add water to the concrete when it starts getting set, and after that the water should be poured until 7 to 14 days, so that all the reaction of cement with water is over and gel is formed and concrete gets good strength. There are so many types of curings. Generally, we do curing by spraying water on the surfaces which are exposed and which are shuttered. We just keep wet outside shutters if weather is hot, otherwise there is no need. Similarly, on the slabs which are exposed to weather, immediately we pour curing compound in the hot weather when it is finished, and after that we cover it with polythene sheets immediately, and after a few hours we uncover the sheets, spread the Hessian bags, Hessian cloths saturated, and then cover the polythene sheets on them, and whole concrete is kept wet for many days, for 7 to 14 days, depending upon the specifications. If it is OPC, we have to give full curing for 7 days. If it is GGBS or PFA replacement, then reaction will be slow, shrinkage will be slow, so we have to increase the time of 7 days to 10 days or 14 days, depending upon the span and upon the types of concrete and the grade of concrete. Without this curing, your concrete will not be a solid material, it will not be hard material or strong material according to requirement. It will be a less strong material. So curing is the heart of concrete. Without curing, concrete is sand. It's nothing. So be careful. Contractors and builders will not take care of this. Even foremen will not take care of this. You have to take care of it. You have to check them. They want to avoid the spread of water and labor on that. They want to save the water. They want to save the labor. That is not the good practice. Then we go to another slide. There's Thanksgiving for all of you. Thanks for viewing and your interest. Please keep in touch. Present by Eng Suraj Singh. Now I'll add into this that you see another file which is now AutoCAD. Let us see there's a drawing, and this drawing one by one I'll show you. Generally for your people on AutoCAD how the drawings are done, and I'll show you now various drawings in this. Let us see. This drawing is architecture. First of all, let me show you. This is one plot, and it is architectural drawing. You can see this architectural drawing. This architectural drawing is prepared for some building, and you can see the plan, how it works, and this is the basement, and you see this is the basement, and there is another. It is showing columns and everything on this, beams, columns. You'll see another snap here, that is also architectural, and you can see this hall and bedrooms, other rooms. You can see this architectural. You can see the drawings. It's showing all complete details, and it's looking very complicated actually, because it's showing columns and total frame of the structure and how it has to be done. Then you can see, go to another slide, I'll show you. Not slide, sorry, it's AutoCAD drawing. I'll show you another one, and this is, you see, you can see here, seeing another floor plan. This floor plan is, this is first floor plan. The previous was ground floor plan, and now it is another drawing which is also architectural, and it is same as before but different floor. It's giving you second floor plan, second floor plan, and next is other floor plan on top. That is roof floor plan, which is terrace, and here is stairs, and then you go. You see the top, and you will see things like this, and you can see that. I'll show you this. You can see these drawings now. You see these drawings. Here is structural, and this is all sections and columns, foundations, basement is this, and you can see this. See, it's all AutoCAD. You will see this basement frames. It's all frames on the structural drawing, and you can very well see this. You can see this. And noting is also there below this. Various notes are given, and these you will find the drawings. Then structural, another drawing. This is structural framing level above, and then you go to other one, other level. You may not understand this, but this is just a glimpse. I'm showing to you about how it works. And if you go to other drawings, and I'll show you here. See, this is now. I'll just give a span on that. The services drawings. Services drawings, which is showing various types of services. For example, here's a service here. Here's a service pipe is coming from the tank. And here's another floor plan of ground, which is also giving you service plan. You can see this this drawing, which is giving you services or manholes, services, and various drawings, various lines, various services, as written here. Similarly, you'll see on the other floor plan, it's like this. You'll see services here in the bathroom, there another bathroom, and similarly you'll find the services here in the another drawing. So it's very important. On all floors you have to see this rainwater disposal. You can see here this rainwater disposal. And on all floors you have to show this as a good engineer or architect. You have to display all information. It's not simply one drawing that we do on many buildings. Waste of time, saving of time, and information is incomplete site. Information must be complete to the site engineer or to the site person, whoever he may be. Without full information, you cannot see you have done the work. These are simply drawings, and these are part of the structural drawings. There are so many other types of drawings which are not given here. For example, perpendicular are not given there. Then you can say here there are electrical drawings. I'm giving electrical drawings. I'm showing you bulb positions and where bulbs are coming, fans are coming. It's also showing you where the fans and where the bulbs are coming. You can see this where decorations are coming, and there's a structure to be for some statue of the god, Sai Baba, or any requirement is upon the client. Then this is also electrical service, another one. In this, you can see all these are shown. Typical bulbs are shown there, fans are shown there. The locations only, like much about. These are the locations of fans and locations of bulbs, and also similarly you can say it's shown here. And I have shown you one. If you can see this, you see this also shown one dining table here. These are all part of the structural engineering, architectural engineering. And if you see now, I'll show you frames. These are all the, you see, first of all, slabs. See the design of slabs, how it's shown. You can see the slab designs are shown. the bars. This is the bars shown in the bar bending position. You can see this is zooming, and it's similarly mesh is shown the other one. This still same as that one, and similarly here you see other one. All the steels are here. One by one, all steel is shown. Other floor plan, so all steel is shown. Then it is another floor plan. All steel is shown. It's a big exercise to do, but on AutoCAD we can save the time. And it is the same steel of all the steels are shown here. And these are the frames, the building, foundations. This is another one, foundations. Then it is frame. I have shown the columns and the beams. You can see this in all frames. See, these are frames 4, 3, 5, 4, 1, 2, and all these are there. Then we have shown the setting out plan. Oh, it's not setting out, site plan. Site plan it is. Site plan. It's showing what area is constructed and what is pending for construction. Similarly, another one, landscape. It's a landscape of the building which is proposed. You can see landscape of the building. Then another drawing just showing some decoration work, some environmental work, into greens in the outside of the building for gardening. This is also same, and we can keep symbols in this, and this is what it's all about. You can see here, various plans, various sections. You can see that, and it's not, I cannot explain everything here, but I try to give you something which is very, very necessary to understand the engineering. It's not simply one-man job, but it involves many people, and they should not say that they know everything. It's group, it's teamwork, and all people have to contribute to any building design. It's very important. This is very, very low stage. Means after that, hundreds of drawings are to be prepared. It's not that easy that we say, okay, we have done this and there's no need of such. And you can say, I'll open this. Let's say another file now. Open. I'll show you another plan. You can see this. You can see the elevation. In color, it is of course. This is one elevation here. You can see this is front elevation, architectural, and this is your elevation. You go to the other one, you will find this elevation here. You'll find the elevation here. See, this is the elevation here, and this elevation. If you go to the other one, you'll find the elevation here. See, this is the elevation here. Then you can say some other elevation here. This is here. And I kept all these elevations in one slot, so you can see this now. You'll see this, how it appears actually. This is the elevation file, and you'll see this elevation in the reverse because it is taken all angles from one plan. There's a plan. Just to save time, I have done one plan, one orientation, and move this front elevation, side elevation, rear elevation, and left elevation accordingly. This is very important from practical viewpoint. You can see this layout plan, how it will look like. That's how it will look like actually. It's like that, you know. It's now going to immensely in this way. So we'll list the previous one. Now, I'll show you now little detailed this. For example, we'll see now this is basement plan which we have kept for household storage, and it is like this here. You'll see. Now I'll show you the columns here. This is the column here. Column. This is column here, and then we see many things. Window, ventilators, etc. are shown, and this is stairs. You can see this is grid D. I have written here grid D. Simply grid D. Then it is grid C. Grid C. Then after that it is grid B. Grid B, and then it is grid A. So vertically we have formed the grid, and basically then if you see this way, or you can see this way, A grid 1, it is like this, x-axis, grid 1, then it is grid 2, after that it is grid 3, here, you can see then grid 4, grid 5, similarly here, the grids are continuing this way. These are columns here. You can see these are the columns here. Columns here. These are the columns. And this is your setting of architectural plan. If you go to the other one, you can see this is also the grid system here, but I not put in here because it was there possible here too. You can see this is bedroom. This is WC. This is another bedroom. This is kitchen. This is bath, this is WC, another one, this is the passages, and then if you go down, you'll find stairs here, and if you go further down, you'll find here, this is one hall, which you are pairing, this is the hall, and this is outside driveway, and this is outside statue, location, some planters here, some planters there. Similarly, on top of that, same repetition here. You'll find here same repetition but different way, because here we added there, and we have used this double height. This is double height hall. This is the first floor plan. If you go to the next floor, you'll find here again bed, WC, multi-purpose hall, bath, and terrace. It's the terrace here. Then you go to more closing. It is terrace next one with top stair portion. And that is the capping type structure on that, inclined structure like this. You see, like this. It's not shown like this, but it should be like this actually. This is the structure. This was done is to keep in the idea of so. These are generally some drawings, not a home. And when you work, you have to produce BBS, you have to produce method statements, you have to produce so many other items which are not that easy, but can be done. Now I'll try to explain to you more about this building construction. You'll see that it's easy to explain, but when you do the work, you have to come in contact with many people. Engineer. He's not simple engineer. He has to produce something, to manufacture something. Particularly building engineer is a civil engineer. In civil engineering, from soil, from aggregate, from raw material, we call it, but these are not raw materials. We mix up them. We produce something useful for hundreds of years, for 50 years. Concrete, block work, brickwork, mortar, foundation materials, separate one for soil improvement. Yes, soil improvement, I I have to explain to you first because it's very important. When you excavate some soil, you will find very weak soil. For example, it's clay, it is silt, or it is slush type. You have to remove that soil because you need a bearing capacity for the soil. You need a strength for the soil. Bearing capacity means how much load soil can bear. A soil can bear, say, 100 tons per square meter. 100 tons, it may be a big load for you, but soil takes that. That is ultimate bearing capacity. We have to check the settlement of the soil, how much settlement it takes. We have to apply the load for some time and it goes down by millimeters, by centimeters. There is a limit for that. Anyway, I explained to you ultimate bearing capacity, that is say 100 I told you, but for purpose of design, we will not take 100, we will take say 30 or 25 like that. That is safe bearing capacity, means the load which remains safe even after the application of load for long times. That is called soil bearing capacity. We have to consider all the factors of wind loads, seismic loads, other loads, dead loads, live loads, vibration loads, and many other types of stresses. It's not simply stresses. We have to estimate other things also, the thermal application, blast application, and sound application, so many things. But generally, for structures, as we have the houses, normal loadings is okay, except the horizontal loads. Horizontal loads are generated by wind load and by seismic load. These are very critical, and nowadays, according to National Building Code 2005, these are very, very complicated, very, very critical, and we have to analyze everything. Now, so for the purpose of foundation, soil bearing capacity, we have to see whether we achieve the required bearing capacity or not. If we can't achieve, we have to remove some portion of the soil, say 100 centimeter, 50 centimeter. We have to take out the bad soil and we have to replace by the good soil. That is called soil improvement. Good soil can be deserts material. It can be sand. It can be aggregates or mixture of that cohesive mix. It can be graded material. We have to increase the bearing capacity by replacing bad material. By taking out bad material and replacing with good material, or by piling, or by stone columns, or by any other method. There are so many methods which can improve the bearing capacity of soil, and nowadays it is done very commonly because without getting the strength you cannot erect the structures, and when you get the strength you can comfortably erect the structures and you can do the job. Because once the structure is done, it's not possible to remove it. It can be removed, but there are millions of rupees or crores of rupees of losses. So it's better that once you think to start a building, you have to check your budget. You have to check that you get a good architect, or you get a good engineer, a structural engineer, a construction engineer, a supervisor, a good services engineer, electrical, mechanical, or whatever is relevant. That engineer should then use for the purpose of designing your building. It may take some money in the beginning for the purpose of design, but it will help you a lot at the end, because for the purpose of building permit, you don't need all these, but for the purpose of execution, every such detail is required. You may spend few thousands of rupees on these activities. For example, you have to pay to structural engineers his fees, to architect his fees, to other engineers fees. You have to pay some money, but your job is done very nicely, your house will be good. But if you don't pay, you may not pay them, but you will save otherwise a lot. For example, structural engineers can make a saving of lakhs to you by using less diameter of steel, and by using less thickness of concrete, and by supervising, by allowing, by forcing you to do the job, to do the curing, and he may help you indirectly. Similarly, architect, if he's a good one, he will cooperate with structural engineer. If he is not good one, he will not cooperate, and structural engineer will not be utilized by you. He will misguide you. Means architect would say, no, structure, don't worry about structure, I'll take care of that. He will copy from the previous job and repeat that. That is not in good sense for you. And generally he will say, just use 25 mm bar or 16 mm bar or 20 mm bar. So there may not be requirement of that. A structural engineer only can understand the realities what are required, and you have to contact the structural engineer directly